everybody, meteorologist Liz McGiffin here, and you may have noticed that after it rains, the temperature goes down significantly. So I want to show you an experiment to let you know how all of that happens. First, let's go over what you need. I'd recommend grabbing a plastic bottle and just filling it up with some room temperature water. Even maybe just let it sit for a little bit so it actually hits that room temperature. You want to make sure that you have a container. In this case, I'm just going to use a clear mixing bowl. Have a wet washcloth full of warm water, warm to hot water. So either get this from an electric kettle, turn the sink all the way up to hot, or even just pipe it in the microwave for a little bit to make sure it is nice and steamy. Since we'll be recording temperature, you want to make sure you have a thermometer, either one of those that go under your tongue, or in this case, I'm using a meat thermometer. All of those will work just fine. You want to have some sort of piece of paper, something to write with so we can record our results. Have some sort of clip. In this case, chip clips will work just fine. And you either need to puncture a hole on the top of this water bottle, or something that'll be a little easier, grabbing something like aluminum foil. We'll get to that in a minute though. First, you can put away, for now, that clear plastic bottle and the washcloth. Within the bottle, like we were talking about, you need to be able to poke a hole in the top. So if you aren't able to quite poke a hole in the top of that plastic part, well, you can take some aluminum foil, something that's easier to press through. You want to make it into a makeshift lid. So close off the mouth of the lid completely. This is going to be good to make sure everything stays inside the bottle, but also to keep our thermometer steady. First thing that we're going to do is actually take the temperature of this bottle of water. So either use your foil, poke a hole in the top, or if you were able to puncture a hole through the lid of your bottle, use this to keep it all steady. Now here is where the pen and paper come in hand. One more thing that you're going to need for this experiment is a little bit of extra time. I'd recommend if you have about 6 hours that you'll be at home, you don't need to monitor this for the whole time, but just make sure the top of each hour you're able to record what time you took the recording and what the temperature was inside of the bottle. So we'll start with hour 0. And it looks like the temperature inside the bottle, 72.1 degrees. Now, the next step that we're going to do, once we've recorded that, set a timer for an hour, and we're going to change up a few things. Now is where you need to have that bowl, just to keep the water all in place. It doesn't matter if you can see through it or not. Have your wet, hot washcloth ready to go, and then you want to completely cover up your bottle with this hot cloth. Once you've done that, make sure that you grab a clip to keep it in place. Again, any sort of clip will work just fine. I grabbed some chip clips because they were what I have at home. Now is when the time part comes in handy. You want to make sure at the top of each hour, you're coming back and recording the temperature that this thermometer says. To save us a little bit of time, I went ahead and did this about 6 hours ago. So I want to share some of my results with you. Now the first thing that you'll notice right off the bat, I had about a 10-degree temperature spike once the cloth was added, what you kind of expect. So after 1 hour and after 2 hours, the temperature actually was warmer than what we began with. But once we hit hour 3, 4, 5, and 6, that's when the temperature not only started to fall, but it actually fell below that 70 degrees that I started with inside of the bottle. Now the reason for this is a process called evaporative cooling, or as the air cools during the process of evaporation. One more thing that you're probably going to notice as you record this experiment at the top of every hour is that not only will your temperature actually start to go down, that's recording the temperature inside of the bottle, but if you touch the washcloth over the course of those 6 hours or even beyond, you might notice the washcloth dries up a little bit more, and you're definitely going to notice it's not nearly as hot to the touch. The reason for this is because evaporation is a cooling process. The process of evaporation, or when the water droplets inside of this washcloth go from a liquid into a gas, well, it takes a lot of energy. And that energy, it happens by the absorption of heat. Once the heat's absorbed, well, the air all around it starts to cool down, and you'll be able to literally feel that on the outside of the washcloth. So, how does this apply to our atmosphere? Well, for starters, if you step outside after it rains, you're probably going to notice a big drop in the temperature compared to before the rainfall started. And that's all thanks to evaporation. So as we start to evaporate those rain droplets or start to dry up those puddles outside, it's a much larger scale as what was happening in and around this bottle. The air just starts to cool down. Another way that you probably see this is on a hot summer day. You're probably familiar with people telling you that when you sweat, it's your body's natural way of cooling off. But just like what we experienced in this experiment and what happens after it rains outside, it's not actually the addition of those sweat beads on your arm that cool you off. It's actually the process of evaporation.